volumetric strain due to 2 mutually perpendicular stresses. Consider a block of length L, breadth B and D as the depth. So that means you have a rectangular block of 3 dimensions of L, B and D, producing the normal stresses along the direction of sigma x, which is on YZ plane, that is, this is Y, sorry, this is Z and this is Y, YZ plane. Then sigma Y, the normal stress, which is on X and Z plane, XZ plane, and also the sigma Z, which is in X and Y plane. So we are considering the 3 mutually perpendicular normal stresses which is acting on the rectangular block. So first we will consider the volume of the block. So what will going to be the volume of the block? The volume of the block, which will be equal to L into B into D. Taking log on both sides, so we will be having the volume of the block V is given by L into B into D. So considering taking the log on both sides, taking log on both sides. So we have log V is equal to log of LBD. So that means log L plus log log B plus log D. Differentiating. Now when you differentiate, what happens? Differentiating. So we have 1 by V, that is log V, 1 by V, that is delta V will be equal to delta L by L plus delta B by D plus delta D by D. So therefore, where delta V is change in volume, where delta V is change in volume, then delta L is change in length, and delta B is change in width, and then delta D is change in thickness or depth. So what we need to find out? We need to find out the volumetric strain. So that is epsilon V is given by volumetric strain, which will be epsilon x plus epsilon y plus epsilon z, where epsilon V is nothing but the volumetric strain. So when we are considering the sigma x, so here what is the sigma x? That will be equal to the tensile stress along the x direction. What is sigma y? Tensile stress along y direction. And what is sigma z? Tensile stress along the z direction. So now let tensile stress along x direction, let tensile stress in the direction of xx, in the direction of xx, which is sigma x. Similarly, tensile stress in the direction of yy, tensile stress in the direction of yy, in the direction of yy, which will be equal to sigma y. Then similarly, tensile stress in the direction of ZZ, in the direction of ZZ will be ZZ, which will be equal to sigma Z. So when you have that, now we will consider, now sigma x, first we will going to consider only the direction of sigma x. So when you are considering the direction of sigma x, when you are considering in the direction of sigma x, we will going to have the tensile strain along the direction of xx, and remaining two directions which will be with respect to y and z, we will going to have the compressive strain. So sigma x will produce tensile stress, sigma x will produce tensile stress which is equal to sigma x by E, which is in the direction of xx, in the direction of xx. A compressive strain which is equal to sigma x by m into E in the direction of yy, in the direction of yy and zz due to sigma x. So once the sigma x is tensile stress, normal stress is acting along the direction of x axis. So what happens? Tensile stress will going to be developed in sigma x. Correspondingly, compressive strain which will going to be produced in the direction of yy and zz direction. So similarly, sigma y will produce tensile strain which is equal to sigma y by E, which is equal to sigma y by E in the direction of xx, in the direction of yy, in the direction of yy. And compressive strain which is equal to sigma y by m into E. Of course it will be negative, that we will see later. Sigma y by E m into E in the direction of xx, in the direction of xx and zz direction. So similarly, if you are considering sigma z, which will be a tensile strain in the direction of sigma z or in the direction of zz, and compressive strain in the direction of xx and yy. So similarly, sigma z will produce tensile strain which will be equal to sigma z by E in the direction of yz, in the direction of zz, and compressive strain in the direction of xx and yy. So this is how it will going to act. So that is basically because when we are applying the sigma z in the direction of zz direction, So sigma z means this one. So you will going to produce, because this will going to become tensile on this particular plane. So naturally this direction will going to be having elongation. So that will be sigma z by E. Corresponding to this, which are all the lateral dimensions? The lateral dimensions will going to be this and this. So this will going to be reduced. So that means it will be on x and y. It will going to reduce us. That means you are going to have the compressive strain on them. So now total stress strain. Hence, what is the generalized Hooke's law says? The generalized Hooke's law states that total strain will be equal to longitudinal strain in the direction considered 2 plus sum of strains in the lateral remaining two directions. So that means you will going to have, so according to the, hence by generalized Hooke's law, that's what we have derived in the last section or in the last video. So wherein total strain will be equal to, total strain will be equal to longitudinal strain, longitudinal strain in the direction considered, in the direction considered, in the direction considered, plus sum of strains, sum of strains which is lateral, that is the lateral dimensions, in the remaining two directions, in the remaining two directions, in the remaining two directions. So which are all those here if you are considering this? So according to this, what happens is the total strain. Suppose if you are considering the total strain along the direction of xx, if you are considering that total strain in the direction of xx, in the direction of xx will be equal to, so what is the longitudinal strain in the direction considered? Now when you are considering the direction x, strain, so that means epsilon will be equal to sigma by E. So that means you will going to have sigma x by E. Then sum of the strains, that is lateral in the remaining two directions due to xx. So what happens? In the lateral directions there will be a reduced in the dimensions of both in case of x-axis. If you are considering this, then B and D will going to be reduced. So naturally, which is B and D? B is along the direction of ZZ and D along the direction of Y. So in that case, it will going to become minus sigma Y by M into E, because Poisson's ratio, what it says, epsilon lateral by epsilon longitudinal. So we want the lateral strain, so naturally 1 by M into the longitudinal strain. So the longitudinal strain is sigma Y by E and the Poisson's ratio is 1 by M, negative because it is reduced in the depth, reduced in thickness. So now once you are considering that, minus sigma Z by M into E similarly. Now total strain in the direction of YY. So total strain in the direction of YY, which is given by, so now the longitudinal strain in the direction considered, which is Y direction. So that means we are considering in the Y direction means, that is D will going to have the increase in length. Then the lateral dimension with respect to that, which will be L and B will going to have the reduction. So that will be equal to, so which is that now Y direction is D. So sigma Y by E minus sigma Z by M into E and sigma X by M into E. So this is with respect to general and this is with respect to the problem wherein you have length D and depth. Now similarly, if you are considering the total strain in the direction of ZZ, which will be equal to sigma Z by E minus sigma x by m into E minus sigma y by m into E. So this is the net strain along the net strain along the each directions. Now next is we need to find out what is the volumetric strain. So the volumetric strain will be epsilon V will be equal to epsilon x plus epsilon y and epsilon z. So according to this, what is epsilon x here? Sigma x by E minus sigma y by m into E minus sigma z by m into E. So this is one thing. Then similarly plus epsilon y, which will be equal to sigma y by E minus sigma z by m into E minus sigma x by m into E. This is epsilon y. Plus epsilon z, which is given by again sigma z by E minus sigma x by m into E minus sigma y by m into E. So now we have all these things. Now on simplification, now we need to simplify this. So to do that, so what we have, the total sum, we know epsilon x, we know epsilon y plus epsilon z, all are positive. So sigma x by E plus sigma y by E plus sigma z by m into sigma z by E minus, now here if you consider sigma x minus sigma x by m into E minus sigma x by m into E, so that will be equal to minus 2 sigma x by m into E. Similarly minus sigma y by m into E minus sigma y by m into E, so you will going to get minus 2 sigma y by m into E. Similarly minus sigma z m into E minus sigma z by m into E, so which will be minus 2 sigma z by m into E. So now when you are considering the common factors, so here in the next step I will write sigma x plus sigma y plus sigma z, sigma x plus sigma y plus sigma z by E. We are going to take that as the common factor. So here 1 by E is the common factor, minus 2 by m into E can be taken outside, and then again you write sigma x plus sigma y plus sigma z. So this is how you can write the above equation on simplification. Now here sigma x by E is a common factor. Here also sigma x plus sigma y plus sigma z by E is the common factor. So we can take sigma x plus sigma y plus sigma z by E can be taken it outside. Then in the flower bracket, so since it becomes 1, we can take 1 minus here 2 by m. So that will be minus 2 by m. So this will be the equation. Therefore, volumetric strain epsilon V will be equal to, therefore volumetric strain epsilon V is given by volumetric strain, which is epsilon V, is given by sigma x plus sigma y plus sigma z by E into 1 minus 2 by m into 1 minus 2 by m. So this will going to be the expression. Suppose if the value of sigma x plus sigma y plus sigma z is equal to 0, then what happens? There will not be any change in the volume. So this is how you will be able to derive this expression for a volumetric strain on 3 mutually perpendicular